Okay, well, welcome to Career Life Ministry here in Cedar Park, Texas. And today we are going to be going through the service entrance conductor calculation, sizing calculation. Okay, there's several steps to this. And so this is going to be a calculation where we're going to find the wire size needed for a single family dwelling. Okay? So this particular single family dwelling, here is a list of equipment that's going to be in this house. The unit itself is measured at 1,350 square feet. The hot water tank is rated at 4.5 kVA. The dishwasher is going to be 1.5 kVA. The disposal is going to be 1.5 horsepower at 120 volts. The HVAC blower motor is going to be 1/3 horsepower at 120 volts. The range, the electric range, is going to be rated at 12 kVA. The dryer is going to be rated at 5.5 kVA. The electric heat in this house will be rated at 12 kW, and we use kW and kVA interchangeably in this calculation. The code lets us do that. And the air conditioning unit is going to be rated at 8.8 kVA. Okay? So the first step in figuring this service-centric conductor size is that we need to calculate our general lighting load. Okay? So in NEC Article 220.40, it talks about these steps. So we're going to take the square footage, 1,350 square feet, and let's take a look at Code Article 220.12. Let's take a look at that code article real quick. Okay, 220.12. When somebody finds it, can you speak up, please? 220.12.
Yeah,
Austin, you got that?
I got it.
All right. And if you can speak up on this, 220.12. So go ahead and read that, Austin, if you don't mind.
A unit load of not less than that specified in Table 220.12 for occupancy specified therein shall constitute the minimum lighting load. The floor area for each floor shall be calculated from the outside dimensions of the buildings, dwelling units, or other area involved. For dwelling units, the calculated floor area shall not include open porches, garages, or unused or unfinished spaces not adaptable for future use.
Okay, so there's a couple of points there. So when we are looking at the square footage area of the dwelling unit, we do not want to include the carports, porches, those areas. So, and it's also telling us to reference table 220.12. So if you turn the page, you can see table 220.12, and there is a list of different types of occupancies on that page, in that table. You have banks, you have churches, clubs, armories, restaurants, schools, stores. We're interested in dwelling units. We're going to be looking at dwelling units. So the square footage, the VA per square foot for dwelling units, does anybody find that?
Mm-hmm.
And what is that?
3.
3 VA, right?
Mm-hmm.
3 VA per square foot. So the first step in the calculation is that we're going to take 1,350 square feet times 3 VA equals what? Anybody get that? 1350 VA times 3?
4050
4050 what?
volt amps.
VA, volt amps, correct. All right. The next step that we want to look at is Code Article NEC 210 11C1. 210.11C1. Let me know when somebody finds it. Robert said 70-52 in the NEC, and we're looking for 210.11C1.
Right here, small appliance.
There it is, off the top of the page. And again, we are using the 2011 NEC. There is a new one that came out this year. So a couple of these code articles may have changed a little bit. A couple may have been added, a couple are revised. Just be aware of that. In this class, we're going to continue using the 2011. So in C1, it says, Robert, you want to go ahead and read that?
Yeah. Small appliance branch circuits. In addition to the number of branch circuits required by other parts of this section, 2 or more 20 amp or small amp appliance or small appliance branch circuits shall be provided for all receptacle outlets specified by 210.52b.
Okay. So we are required to install 2 20 amp branch circuits, and let's see. In those small appliance branch circuits, there was another, let's see, there's another item here I wanted to look at. Let's look at 210.52b. 210.52b. B. Okay. That's on page 70-56 of the NEC. And so again, it talks about the small appliance receptacle outlet served. It says, in the kitchen, pantry, breakfast room, dining room, or similar area of the dwelling unit, the 2 or more 20 amp small appliance branch circuits required by 210.11C1, that's what Robert just read, shall serve all wall and floor receptacle outlets covered by 210.52a, all countertops outlets covered by 210.52c, and receptacle outlets and refrigeration equipment. Okay. All right. So, let me see here. I'm looking for the small appliance branch circuits. We give it a VA rating of 1500 VA each, and need to go back to see where that was located at.
Section 220.52a.
220.52a, Austin says. Right, 220.52a. Let's take a look at that. .52a. Okay, there it is on page 7065. Small appliance circuit load. For each dwelling unit, the load shall be calculated at 1500 VA for each 2-wire small appliance branch circuit as covered by 210.11C1. Again, that's what Robert read, telling us that the code requires 2 small appliance branch circuits in the dwelling. And if you continue reading in that paragraph, towards the end of that paragraph, it says, these loads shall be permitted to be included with the general lighting load. That's what we're calculating right now. It shall be permitted to, with the general lighting load and subject to the demand factors provided in table 22042. Now we're going to get to those demand factors in a minute. So the point I want to make is that the code says add 2 small appliance branch circuits to the general lighting load and at 1500 VA each. So we go 2 small appliance circuits at 1500 VA. That equals what?
3,000.
3,000 VA. 3,000 VA. Okay?
Yes, sir.
Okay. Then we go on to the laundry circuit. The code also requires that the dwelling have one 1500 VA laundry circuit installed. So if we look at, and that's also in 210.11C1. So going back real quick to 210.11C1. C1, however when you get there. 210.11C1, there we go, page 7052. Actually, that's going to be 210.11C2. Okay? C1 is the small appliance branch circuit, C2 is the laundry branch circuit. And so it says, in addition to the number of branch circuits required by other parts of the section, and at least one additional 20 amp branch circuit shall be provided to supply the laundry receptacle. So in the laundry room, you have your washing machine, and what voltage is that at?
220.
Washing machine?
120.
120, right? And also in the laundry room, often, you know, some ironing gets done, and so there is a dedicated circuit for the laundry room that's required by the code, and that's for your washing machine and for ironing your clothes and all. Okay, nothing else can be tied to that circuit. Okay, so we read that in 210.11C2, and then we go back over to the 220.52B this time, and it says the laundry circuit load, a load of not less than 1500 VA shall be included in each 2-wire laundry branch circuit installed as covered by 210.11C2 that we just read. Okay? And it says this load shall be permitted to be included with the general lighting load and subject to the demand factors provided in table 220.42. So we can add the laundry circuit to the general lighting load, and we apply a 1500 VA rating, okay, to that load demand. So we'll go with laundry. One. At 1500 VA. Okay, so we got a 1500 VA laundry circuit now. Okay, so the next step then, for the general lighting load requirement. So we want to add all those up. Somebody add those up for me, please?
8550.
8,550
Yes, sir.
VA, right? Okay, now the code recognizes that, you know, we're probably not going to have every light on in the house. We're probably not going to have the laundry circuit all energized, and we're probably not going to have both small appliance circuits fully loaded, you know, and all. And so they give us a demand factor on that. And so the way it works is that they say, let's look at let's look at 22042.
General light.
NEC 22042.
64. Yeah.
Holler when you find it.
Same page.
22042, no?
64.
7064, right? Okay. So 22042. Blake, can you read that one, please? 220.
The demand factors specified in table 220.42 shall apply to that portion of the total branch circuit load calculated for general illumination. They shall not be applied in determining the number of branch circuits for general illumination.
Okay. So again, we're talking about service entrance conductors. We're doing a calculation on sizing the service entrance conductors, the two hots and the neutral coming into the dwelling. This has nothing to do with the branch circuits, okay? So it says to look at table 22042. And in 22042, it says for dwelling units, okay, there's hospitals listed there, hotels and motels, warehouses, all that's listed in that table. We want to focus on dwelling units. And it says you take the first 3,000 VA or less. First 3,000 VA at 100%. Okay. So we're going to go. Let's see, 85, 50 minus 3,000 is 55, 50. So we're going to go 3,000. Let's see. We're going to say 3,000 VA. All right. And so there's 5,500 VA left. What does it say to do with the next 5,500 VA? Then it says from 3,001 to up to 120,000 VA that remains, to take that at 35%. You see that in the table? Mm-hmm. Okay. So we take that 5550, we multiply it by 35%, 0.35. What is that?
1943.
Say again?
1943.
1943. So 1,943 VA. And if you add those up, what do we get? $3,019.43 VA.
4943.
49.43 VA.
Yes, sir.
Okay. 49.43 VA. All right. That's our general lighting load part of this calculation. Okay? Any questions on that?
Negative.
Yes, sir.
Everybody okay?
Yes, sir.
All right. Next, we're going to move on to our fixed appliance loads. Let's take a look at Article 22014. Okay. Let's see. This is here. Okay. So fixed appliances, we're talking about, what kind of equipment do you think we're talking about for fixed appliances?
Hot water tanks, dishwashers, disposable, or
Blower
disposals.
motors.
Right, so it's gonna be your hot water, your dishwasher, disposal, things that are fastened in place that you can't move, right?
Mm-hmm.
Just a second, let me check on something here. So this does not include the, this does not include your electric ranges, your heating equipment, air conditioning equipment, you know.
No.
This is not included in that. This is not what they're talking about. For fixed appliances, we're talking about the hot water tank, dishwasher, disposal, the blower motor for the HVAC system. That's what we're talking about here. Okay, so the hot water tank, what is the KW or the KVA for the hot water tank?
4.5.
4.5.
240 bucks.
Okay. So, hot water. 4.5 kVA. Okay. And looking at our equipment over here, what else do we have that we can apply as the fixed appliance?
Dishwasher, you got?
Dishwasher? Okay. And dishwasher is rated at 1.5?
Yes, sir.
Okay. All right. And what else we got?
Disposal?
Disposal? Okay. Now, we don't know what the VA is for the disposal though, right? So what we're gonna have to do to find the VA for the disposal is we go to 430.17, this in Article 430, that talks about motors, okay? So we go to 430.17 in your NEC. Robert said page 70-316, Article 430.17. In determining compliance with 430.24, 430.53B, and 430.53C, the highest rated or smallest rated motor shall be based on the full load current as selected from Table 430.248, Table 430.247, Table 430.249, or Table 430.250. So if you look at those tables, you should just turn the page here. Let's see, 430, 249. Let's look at table 430, 249. Okay. It's actually, okay, on page
It's
70 dash
337.
Okay, on page 70 337 is correct. It's right
Right.
there, 430, 248. So on these couple of pages, it shows the full load current amps of different types of motors. You got your DC motors. You have two-phase alternating current motors, 4-wire. You have full load current ratings of single-phase AC motors. On the next page, you go into 3-phase motors. We're going to be looking at single-phase 120-volt motor. And in this case, the disposal is a 1/2 horsepower. So we go down the 1/2 horsepower column
9.8.
and we look at what's the closest. We got 115 volts.
9.8.
It says 9.8, right?
Mm-hmm.
Okay, so we have 9.8 amps, and we're looking at 120 volts. So what is the VA for that motor? Somebody figure that out?
1176.
1176, Robert?
Yes.
1176 VA. Okay. So we just take our full load amps times our voltage, and that gives us our VA rating. Okay. What else do we have that's fixed appliance?
Hot water. Oh, HVAC blower.
The HVAC blower, which is at 1/3 horsepower at 120 volts, right?
Mm-hmm.
Okay. So on that same, in that same table, we look up 1/3 horsepower motor.
And it's 7.2 amps.
Okay, and 7 point what?
2?
7.2?
Yeah.
And what's the VA on that?
864.
864 VA. Okay. So we have our hots, we have our neutral. Okay. And so for the blower motor, let me back up. For the hot water heater, what voltage level is the hot water heater run at?
240.
240, right?
Sir.
So we're going to put 4,500 underneath each of the hots. That's going to be hot water. All right. Then the dishwasher is at what? What voltage level?
120.
120. So we have a neutral now, right?
Yep.
So we're going to put 1,500 on the neutral, and $1,500 on the hots. we're gonna make both hots the same size, so I'm just gonna go ahead and add that VA to each of the hots. The code allows us to put a demand factor on the neutral, make the neutral a smaller size, and so towards the end of this calculation, we'll see what that looks like. But we'll go ahead and continue working through this. The disposal, what voltage level is the disposal?
120.
120? It's going to be, and that's at 1176 VA.
Yes, sir.
So we have to add that to the neutral also. We add the 1176 to the neutral also. And then finally the blower motor in this house is going to be what
120.
voltage?
120.
120. So we take the blower, we go
864.
864 on the neutral and on the hots. Okay? Okay, so let's go ahead and add these up. What is the total VA for the hots? Just the hots.
60, 30. 6,030.
At 100% or 75?
Okay, so we're just gonna do the
75
hots
for
at this
two
time?
hots.
Right.
So, and then we're gonna look at, so the total VA at this time, total VA without any demand factors is what?
60-30.
60/30. And the total VA of the neutral is what?
3,540.
3,540?
Yes. No, 3,540.
Okay. So that's the total. But the code allows us to, okay, I think I misspoke a second ago about the demand factor on the neutral, which the code does give us allows us a demand factor on that, but the code also allows us a demand factor when we have 4 or more fixed appliances fastened in place. Okay, we can take that at 75%. So let's look at Article 22053. Article 22053. It's like on page 70-65. Everybody got it? Okay. Austin, can you read that? 220.53.
It shall be permissible to apply a demand factor of 75% to the nameplate rating load of 4 or more appliances fastened in place, other than electric ranges, clothes dryers, space heating equipment, or air conditioning equipment that are served by the same feeder or service in a 1-family, 2-family, or multi-family dwelling.
Okay, so when we look at the fixed appliances fastened in place, the code allows us a 75% demand factor for 4 or more appliances, but they cannot, like the article said, it cannot include the dryers, electric ranges, space heating equipment, air conditioning equipment for a single family or multifamily dwelling, okay? So, you know, because the code is recognizing that, you know, we're probably not going to have the hot water heater energized and have the dishwasher going and the disposal going continuously and the blower motor running continuously all at the same time. So it's giving us a little bit of a demand factor in there. They're saying, okay, take 75% of that, okay? A few of these could be running all at the same time. So it says, you know, so again, this is for size of the service entrance conductors, not the branch circuits. And so it's saying it's going to give you a 75% demand factor. So you take the HOTS,
It looks
how
like
many,
they already
how
did
many, how many fixed appliances do we have fastened in place right here?
4.
that. 4.
4, right?
Yeah.
It looks like they already took the 75%. What
Yeah,
it
we
was,
did.
60-30.
Oh,
Yeah,
you're,
we did.
okay, I didn't even add that up. I'm
Yeah.
gonna have to check the math now, okay? Okay.
Sorry.
It's
All right.
80-40.
So this is with, okay, so this is going to be with the 75% demand factor, okay? So I'm just going, so I'm gonna erase this guy though. So, 60-30. Okay, total at 75%. Okay? Now, can we apply that demand factor to the neutral?
No,
Why? We applied it to the HOTS,
because it's only 3.
because it's only 3, right, Robert? We don't, on the neutral side, on the 120 volt side, we only have 3 appliances fastened in place. We don't meet the requirements of that code article. You gotta have how many at least? At least 4, right? So the neutral does not have 4 appliances fastened in place. So we have to take the neutral at 100%, okay? So, the neutral is going to be what?
3,540.
3,540 VA. Okay? Total at 100%. Okay? Okay. All right. Okay, that takes care of the fixed appliance part of this calculation. What haven't we addressed yet? What other loads have we not talked about yet?
Other loads?
Other loads. What do other loads consist of?
Electric range, the dryer, the heating, the air conditioning.
Okay, the range, the heating, the air conditioning, right? Okay. That's what we're going to do down here. Okay, so let's take a look at that. Other loads. Let's look at 22014. Article 22014 in your code. Page 70-61 in your NEC. Okay? Okay, so it says, Robert, you want to read that?
Okay. In all occupancies, the minimum load for each outlet for general use receptacles and outlets not used for general elimination shall not be less than the calculated in 220.14a through L, the load shown being based on nominal branch circuit voltages.
Okay. And so when you look through A through L, it's talking about the electric dryers, electric cooking appliances in dwelling units. okay? And motor loads, luminaires, heavy-duty lamp holders, signs and outline lighting, show windows, fixed multi-outlet assemblies, dwelling occupancies, and banks, office buildings, and other outlets, okay? So, we have not addressed the range, we have not addressed the dryer, the heat, air conditioning like Austin was mentioning. And then also, we need to also consider the largest load, the largest motor, okay? We have to take 25%, an additional 25% of the largest motor. And we'll talk about that in a minute. So, the electric range, what is the range calculated at?
12 kVA.
12 kVA. Okay? So let's take a look. Let's take a look at Article 22055. On page 70-65. Article 22055 at the bottom of the page. Everybody there? Okay. It says electric ranges and other cooking appliances for dwelling units. The load for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated in excess of 1 3/4 kW shall be permitted to be calculated in accordance with Table 22055. kVA shall be considered equivalent to kilowatts, okay? So on a stove, you have resistive heating elements, which is really, you know, power is measured in watts. The code is saying here that, you know, we're going to consider kVA and watts, you know, the same way. And so it's saying here, if we go over to the next page, turn your page. The code also allows a demand factor for the range, okay? The code is recognizing that, you know, we're probably not going to be burning all 4 burners and having the broiler and having the oven on with the light and, you know, everything all at the same time at its highest temperature, okay? And so it gives us a demand factor to apply. And so if we look at the number of appliances in column 1, so if we were doing an apartment, this would be a different calculation, but we're only doing a single-family dwelling unit. We only have one range. There are homes in California and some places, you know, and I'm sure in Texas too, where some of these houses have more than one kitchen, you know. They have a couple of kitchens, you know, and you know, they're huge houses. It's not uncommon anymore. But in this particular house, it only has one kitchen and one range. So, what was the rating of this range again? Somebody tell me? 12 kW, right?
Yes.
And we only have one. So you look at the number of appliances, and you go over to column C, because column C says the maximum kW, not over what? Not over 12 kW, right? So we're looking at column C, and the demand factor for that range is what?
8,000 VA.
8,000 VA, right? So, per code 22055, column C, okay? 220.55 C. the demand factor is going to be 8,000 on the hots. Okay. Right? Okay. Now, let's take a look at the neutral. On a range, we have, what do we have on a range? We have a oven light, we have a timer, we have what the control panel light, and so there's a couple of 120 volt circuits on this range. So we run a neutral to the range also, right? But we don't need to apply the same VA rating that we have on the hots on the neutral. So the code allows us to give a demand factor on the neutral. So if we look at Article 22061B, 22061B, it says feeder or service neutral load. And it says, if you look at permitted reductions, okay, everybody find that in the code book?
Yes.
Page 70-67. It says a service or feeder supplying the following load shall be permitted to have an additional demand factor of 70% applied to the amount in 22061B1 or portion of the amount in 22061B2 determined by the basic calculation. So it says the feeder or service supplying household electric ranges, wall-mounted ovens, counter-mounted cooking units, in electric dryers where the maximum unbalanced load is, has been determined by table 22055 for dryers, okay, or 22054 for dryers. So it says here, basically what they're saying is that we can take the demand for the range and apply a 70% demand factor to it. So on the neutral, this is for the neutral now. So we take 8,000 VA times 70%. What's that going to be?
5,600.
5,600?
Yes.
Okay. And so other loads, the neutral, we talked about the demand factor on the neutral. And that's for the range, that's 22061B. Now we're going to look at the dryer. And the dryer is rated at what? Let's look at 5.5 kVA, right? So let's take a look at NEC Article 22054. Okay.
Demand factor of 100%.
So it says the load for the household electric clothes dryer in a dwelling unit shall be either 5,000 watts VA or nameplate rating, whichever is higher. Okay. So if the dryer was 4.5 kVA, what would we have to? What would be the demand that we would give to the dryer if it was 4.5 kVA? Based on what it says there.
It would be 4,500.
It says, shall be either 5,000, it says that load for household electric clothes dryers in a dwelling unit shall be either 5,000 watts VA or the nameplate rating, whichever is higher. So if the KVA is only 4.5,
It's gonna be 5,000.
we have to give a demand of 5,000.
Right.
In this case, the dryer is what, 5.5 kVA, and so we have to apply 5.5 kVA demand factor. Okay, so
And the demand factor is still 100%.
the dryer, we're going to put 5,500 on the hots. And then the neutral, is going to be again for the dryer, because what do we got? We got a light inside the dryer, we got the timer, we got a light on the control panel of the dryer. So that's a 120 volt circuit, so we have to run a neutral to the dryer. And so we are looking at article what?
NEC 220.61.
22061, right? B.
70%.
And 22061B, again, just like on the range, we can give the neutral a 70% demand factor because we don't need as much power on the neutral, you know, as we do on the heating elements in the dryer. And so 5,500 times 70%,
3,850.
3,850,
Yes, sir.
okay? All right.
All right.
Next we got electric heat and we have air conditioning. Now if we look at Code Article 220.60, let's take a look at that, 220.60. Let's go back one page. On the bottom of the page, 220.60. Robert, can you read that?
Yes. Non-coincident loads. Where it is unlikely that two or more non-coincident loads will be in use simultaneously, it shall be permissible to use only the largest load or loads that will be used at one time for calculating the total load of a feeder or service.
Okay, so the code recognizes that, you know, for sizing the service entrance conductors, we are not going to have the air conditioner and the heater running at the same time, okay? So what the code is saying is that whichever is larger is what we have to size for.
Okay.
So, with that said, the electric heat is rated at what?
12 kVA.
12 kVA. And the air conditioner is rated at what?
8.8 kVA.
So which one are we going to use?
12.
12 kVA, right?
Yep.
Okay. So, electric heat. Is going to be 12,000. 12,000. And that's, what kind of equipment is that? What voltage is that? Chris, what voltage is the electric heat?
220?
220, right?
Yeah, 20 was fine.
Okay. So, and so we don't need to run a neutral for that, okay? But what about the blower motor? Well, we got the blower motor over here, right? We calculated for the blower motor over here, okay? So, the electric heat, 12,000 watts or 12,000 VA. Okay. And then the electric, and so the air conditioner, air conditioning is going to be omitted per NEC, what? Per NEC 22060. Okay. the last thing we gotta do is consider the largest motor. Okay, we need, so let's take a look at Article 430.24. Again, we have to go back to the motor section of the code. That's in the 430s.
$318.
430.24. And let's see. It says several motors or a motor and other loads. And so that's what we have. We have a motor and other loads. So conductors supplying several motors or a motor and other loads shall have an ampacity not less than the sum of each of the following: 125% of the full load current rating of the highest rated motor as determined in 430.6a, sum of the full load current ratings of all the other motors in the group as determined by 436a, 100% of the non-continuous non-motor load, and 125% of the continuous non-motor load. So if we look at number 1, 125% of the full load current rating of the highest rated motor, the highest rated motor is what? What is the largest motor in this dwelling unit?
The blower.
The blower. Blake said the blower motor. Okay? What is the rating of the blower motor?
It's actually the disposal.
Yep.
Oh, the disposal.
Disposal.
Yeah.
The disposal, right?
It's
1176 is the largest one. Okay? So, now we have 100% of the rating already figured in the fixed appliance loads. Okay? We have 100% of that rating already figured in. What's the code saying we got to do though? We got to take it at 125%. So we're going to take that disposal and take 25% more of that. Okay? So, largest motor. Is going to be the disposal. And that's going to be 1176 times 0.25. And what's that going to be?
294.
294? 294. And because that's a 120 volt motor, we're going to put that on the neutral also. Okay? Now we're ready to add. Okay? So, the sum of our hots, just our hots, what is the sum? I'm trusting y'all with your math here.
37,917.
What you got, Chris?
37,917.
37,917.
Mm-hmm.
That sounds a little high to me.
Yeah.
Yeah, that's too, but it could work.
Yeah, it looks like 25,794.
Yeah. You can't count.
So we got 12,000 for the heat.
You said it's 12,000.
Okay, we got 12,000 for the heat.
Yeah.
We got 8,000 for the range. That's 20,000. The dryer is 25,
One too many.
or
12s.
the dryer is 5,500. So that's going to be 25,500.
I added an extra 12,000. That's my mistake.
That's for expansion, for future
Yeah.
growth, right?
Uh,
Okay.
Don't we have the air conditioning though?
Not the air conditioning, but because of Article
Oh, so
two
it's
twenty
updated.
sixty,
That's
They
the
don't
why.
largest
need
of the two.
That's why I had that extra 12 on there.
Yeah, yeah, the largest of the two. So
Alright.
25,794. Does that sound right?
Yes.
Okay. What about the neutral?
$9,744.
9,744.
Yes, sir.
Okay. Okay. That's other loads. So we did the general lighting, we did the fixed appliances, and we did the other loads. So let's add it all up now. The general lighting. So we got hots, we got the neutral, we got the hot. So general lighting is going to be what? Second. General lighting,
49,
we
43.
have 4943 VA. And that's going to be on the hots and neutral. 49, 43. On our fixed appliance,
3,540 for the neutral and 6,030 for the hots.
fixed appliance, tell me again there, Austin?
6,030 for the hots
6,030 for the hots,
and 3,540 for the neutral.
3,540 for the neutral. Okay. Other loads?
107.475 is your phase.
Tell me again, Chris?
107.475.
107.
0.475.
That was 25,794.
Yeah.
Yeah, divided by 240.
No, I don't want that. I just want the VA.
Oh, I'm
Yeah.
sorry.
Yeah, I just want the VA right now.
Yeah, that's 25,794.
25,794. 25,794. And the neutral, VA,
9744.
9744, right? 9744. Okay. So let's add all those up. The hots, what is that total?
36,767.
49, 43. $60.30. 25,794. 36,767.
Yes.
And the neutral? Tell me again, Robert?
18,227.
Do y'all agree with that? 18,227?
Yeah, I did.
Okay. Now, so what we do now, so this is the total VA. Total VA demand. Okay. Now we want to divide it by 240. So when we divide by 240, what do we get?
Approximately 153, rounding up.
153.2.
36,767 divided by 240.
Mm-hmm.
153.
Oh, I'm sorry, not rounding up.
0.19, we can go 153.2, right?
Yep.
And what does that represent?
That's your amps.
Those are the amps, right?
Yeah.
Okay. What about the neutral?
76, 75.9 rounded up to 70.
75.94. Go to 75. Let's just go to 75.9. Right? Okay. So the amps, we need 153, about 153 amps, and we got wire, and we need wire for at least 76 amps, right? So let's look at the table 310 15B. We're almost done with this calculation. Three 1015B. B16, 31015 B16. 70-154. Okay? All right. So for our HOTS, what size wire are we going to need? 90-degree wire. We want to use 90-degree wire here.
Copper, right?
Copper. 90-degree copper wire. What size wire are we going to need for 153.2 amps?
1 aught.
Mm-hmm. 1-aught wire.
1-aught wire. That's good for 170, right?
Yeah.
Sir.
What if we were to use 75-degree wire?
It would burn.
What size wire would we need?
2-aught.
2-aught?
Mm-hmm.
Okay. 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 So we would use 1-aught, which is good for 170 amps. We also have to consider what the temperature rating is for your panel board, okay, you know, for your equipment. You know, so if it's based on 60 degrees, 75 degrees, or 90 degrees, you have to utilize that column, okay?
Mm-hmm.
And then size your conductor accordingly. Okay. So that's 170, so that's going to be 1-aught wire. Remember 1-aught AWG and we'll just say THHN, okay? So we want to use 1/0 AWG THHN, which is good for 170 amps, right? Okay. Now, okay, what about your main breaker, your overcurrent device? So if we go over to Article 240.6, on page 70-91. 240.6A gives you a list of standard breaker sizes, okay?
We need 170.
And so, what size are we going to need for this
175.
for this panel? 175. Okay, the
Because
code.
our total
if there's-
average is 153.
Right. So if there's not the code allows that if there is not a standard size breaker that's protecting the conductor, the size of conductor you know that you're installing, that you can go up to the next standard size breaker. Okay. So in this case, the 1/0 THHN conductor is good for 170 amps. So it'll let you go up to 175 amp breaker. Isn't that okay? Okay. So we'll go main breaker. (175 amps). Okay. What about the grounding electrode conductor? We need to size the grounding electrode conductor. So we need to look at 250/66A. 250/66A. And it says here, size of the alternating current grounding electrode conductor, A, connections to a rod, pipe, or plate electrode, so we use a rod, 8-foot ground rod, where the grounding electrode conductor is connected to a rod, pipe, or plate electrodes as permitted in 250.52A5 or A7, that portion of the conductor that is the sole connection to the grounding electrode shall not be required to be larger than number 6 AWG wire or number 4 AWG aluminum. So it says that it's not, because we're going to be connecting to a ground rod, it's not required to be larger than number 6. But if you look in that first part in just 250.66, there's a table that it references. It says the size of the grounding electrode conductor at the service at each building or structure where supplied by a feeder or branch circuit or at a separately derived system of a grounded or ungrounded AC system shall not be less than given in table 250/66 except as permitted in 256A through C. So in A it says it doesn't have to be larger than number 6 AWG. But if you look at the table on the right side of that page at the top, it says size of the largest ungrounded service entrance conductor. That's our HOTS, right? So what is the size of our HOTS? 1 aught, right? So it says for number 1 or 1 aught wire, copper, and we're going to use copper grounding electrode conductor. It doesn't have to be any larger than number 6. Okay, we can use a number 6 wire for that. Okay? So that's number 6 grounding electrode conductor. Grounding electrode conductor equals number 6 AWG. All right? Let's see. We pretty much covered everything. We need to have what size panel board? What's the minimum size panel board we need for this dwelling unit?
175 amps.
175 amp panel board is what we want to use, right? Now, you know, as electricians, you know, it's good to oversize a little bit, you know, to allow for future growth. You know, the owners of the house may want to install a swimming pool or enclose the garage or add on to the house, and so it'd be good to have a little extra capacity there, you know, in your panel board and in your service entrance conductor calculation to provide for that. But this is, you know, the minimum that we have to have, okay? Let's count the number of spaces we're going to need in that panel board then, okay? The general lighting load is how much? What was the VA of the general lighting load?
40-50?
40-50. We take that to find amps, what do we do? To find amps, we got 40-50, 4,050 VA. We need to know how many amps that is for general lighting. So we're going to what?
Divide that by 120?
Divide that by 120, that's correct. How many amps is that?
33.75.
33.75. How many 15 amp breakers or spaces in that panel board are we going to need for to cover 33.75 amps using 15 amp breakers? How many circuits is that? How many 15 amp circuits is that going to require?
How many?
Just for the general lighting load?
Just for the lighting.
3.
Three 15 amp circuits, right? That'll be good. That'll be good for 45 amps, right? 2 won't cover it, right? 2 is only going to be good for 30 amps, and our demand is 33.75. Or we could install 2 20 amp circuits. So we'll go with 15, you know, for this sample, okay? Example. Okay, so we need 3 15 amp circuits, so that's going to be 3 spaces, okay? We need 3 spaces for the general lighting. What else do we have? We have the small appliance. What does the code require us to install in the kitchen? Remember? Two 20 amp small appliance circuits, right? That's for your electric skillets, your blenders, your toaster ovens, and all. So the code requires that we install 2 20 amp circuits. That's going to be 2 breakers at 20 amps. That's 2 spaces. Okay? What else do we need? The code also requires we install what?
One laundry circuit.
A laundry circuit. How many?
1.
That's gonna be one space in that panel board we need to dedicate for the laundry circuit. What else?
Hot water tank.
Hot water heater, okay? So a hot water heater, how many volts is that?
240.
240.
Two for it.
Need 2.
Two spaces on the panel board for the hot water heater, right?
Let's get 1. Dishwasher.
Dishwasher, what voltage is that?
120.
120. How many spaces we need for that?
Oh no.
What else we got?
Disposal.
Disposal? Okay,
Need one.
need one for that. What else we got?
Blower.
The blower motor. One for that.
Yeah.
What else we got?
Electric range.
Electric range.
Two for that.
Yeah.
Two for that.
2.
What else we got?
Electric dryer.
Electric dryer. What voltage is that?
120.
120.
Why?
Oh, wait.
It's 220. 240.
Okay, so how many spaces in the panel board for
Two.
that? Two. What else we got?
Electric heat.
Electric heat. At what voltage level?
240.
240.
240.
Those.
And we have to
Air
run a
conditioning.
circuit for the the air conditioner unit.
Yes, sir.
240.
Yes, sir.
What else? Anything?
No, that's it.
No, we're missing something. It's only 910.
The code also
You're
requires.
talking about the largest motor.
No,
No? Darn it.
we're only looking for circuit spaces in the panel board for the circuits. We need to install a bathroom circuit. Okay, a bathroom circuit. What requires a bathroom circuit? Okay. So what does that add up to?
20.
3, 5, 6, 8, 9, 10, 11, 13, 15, 17, 19, 20 spaces in the panel board. Spaces. There you go. So, that wasn't so bad, was it?